record this lesson. Right, we are recording now. If you've got any messages, you can put them up in the chat as we go along. So first of all, I want to show you exactly, okay, I'm going to go exactly, I'm going to present my screen. Well, what am I doing? Presenting my screen, change layout, stop recording. Oh, what can you see? Can you see my screen or not?
We can.
I don't know what's happening here. Oh, right, so you can see my screen. Good. Thank you for that. And I don't want the whole screen. I want to go and show you what to do. So under my Google site, so first of all, sorry, we should go to Google Classroom. Under Google Classroom, you've got this. So I may be putting some more up here. You go to the Google site sign in here. And when you go to the Google site, you go to calculus, we're doing conics, but now we're going to start on complex numbers. So when you go to complex numbers,
sure.
I've got some videos to get you underway in complex numbers. I've got the Surds 1, Surds 2, and down here I will put the video link under complex numbers. So I'll also put on Google Classroom so you can come back and watch this video link. So the work under this videos on complex numbers, I've linked to Mr. Chandakay's Infinity Plus One. You've got 25 videos on complex numbers, so we need to learn those things. I've got some trans-sum activities on Surds 1 and Surds 2. This is your work for most of this week. I will probably add to this, so see how far you go and ask questions, send them to me. But we do expect you to keep your learning going. So I'm going to go over what Surds are. But just a reminder, your practice activity for the conics, I gave you the practice activity. You've got a practice activity on Easter eggs. We gave you the other one on the Colosseum, and you can finish that off, and Mrs. Al-Salihi will be showing you the task for that. We haven't decided when we'll reschedule the assessment for this, but it can't be this Thursday. It'll have to be at school where you can have under exam conditions. Right, so we're going to start on complex numbers. So under complex numbers, I've got a question here. Is there an actual number that when multiply itself equals to -1? Okay, so hopefully I can see in the chats here that, no, that's my last one, was it? Yeah, that was my last class. This one here. This one here. Yeah. Hold on, what's that? Right, I've got the things here. Can you see, can you hear? Oh, we can see this. Right, it's all good now. Good. Okay, I was a bit worried there. Okay, so I want to see these comments on the side there. So I'm going to have two screens up here. Now, answer this question. Does an actual number exist when multiplied by itself equals -1? So something times itself equals -1. Is there anything that you know where this exists? Type it in the comments there. Yes, no, don't know. I want you to think. No one's willing to answer. Unless, okay. I times I. Okay, so you've got the I. But does I actually exist, Wesley? You're correct. There is a number, we call it I. The number I. But what is I? Can we express it in terms of digits? Like we normally express the number 10. You know, you can express the number 10 in two ways, or many ways. You know, this is the normal way we express the number 10. We can express it as 2 times 5. We could draw tally charts like this. So we've got this number I here. The square root of -1 is I. But what is the square root of -1? Can we actually give it a digital number? Can we actually put digits here like the numbers 10 or 2 times 5? Can we express it other than I? What do you think? People are thinking hard. Maybe you haven't woken up yet. We can actually do it. I'm going to teach you a method. I'm going to convince you over a period of time, and I'm going to take it really slowly. It's quite interesting that we can actually find a number. But first of all, I want to introduce you to number bases. Have you heard about number bases? So if we are working in, say, base 2, in base 2, well, first of all, we often work in base 10, right? These are the digits that we use, 0, 1, 2, 3, right up to 9. We use 10 digits, 10 single digits, before we go into doubles. So counting 0 as a digit, and we've got these other 9, we use 10. That's base 10. But if I was to use base 2, I could only use 0 and 1. So let's start counting in base 2. 1, and we can't have anything with 2, 3, 4, 5, 6, 7, 8, 9. They're missing. So the next one we can do is 10. That's my second number in base 2, is 10. I can also have 11. My third number in base, that's my third there. My fourth number in base 10 is 100. Then I can do 101. Then I can do 110. Then I can do 111. What's the next one there? Type it in if you know. We'll call it out. Who's going to be first, second? Yep, it's 1,000. And then we can go, the next one would be 1,001. What's the next one after that? 1,010 is correct. And the next one after that? 1,011, good. And the next one after that? 1,100. And the next one after that? 1,101, 1,110, 1,111. Oh, 2,000? No. What's the next one after that? Yes, good. Okay. So some of you are understanding about base 2. Okay, so all I want to introduce is there are different ways of expressing numbers. And we're going to be looking eventually at base 5. So the next lesson, I'm going to ask you about base 5. And we're going to do some counting in base 5 because the square root of -1 actually exists in base 5. So we need to learn about base 5. And I'm going to give you a number in base 5 that when you multiply it by itself, you'll see equals -1. So that's pretty cool. So imaginary numbers is what I normally is, but we'll get onto it later. So that's just an introduction. If you don't understand it now, we'll go over it again later. But today we're going to have a look at surds. Right? So surds are non-repeating decimal numbers. They're normally square roots. So square root of 2 is called a surd. Now most numbers are rational numbers. Rational numbers means that they can be expressed as a fraction. So rational numbers are fractions, and b, of course, cannot equal 0 because you can't have any number underneath 0. So rational numbers are fractions, but irrational numbers are non-repeating decimals. So they are decimals that don't repeat, and they go over and over itself. Pi is an irrational number. It's 3.14159, blah, 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 blah. Goes on, and there's no repeating pattern, although there is a lot of design in there. We've got E is another irrational number. It's 2.71, I think it is, and it goes on. We have other irrational numbers, like square root of 2. Now I'm going to bring up a Desmos calculator here. I think I've got it here. Is this it? No, whoops, what have I got? Where's my Desmos calculator? Okay, I have to go to a new tab. I'll just do it here. Okay, Desmos calculator. This one here. And so if I do the square root of, whoops, what's happened there? Square root of 2, we see that we get our answer. I have to shift this along. There's 1.4142135. Now, this is a non-repeating decimal because after the 1 here comes the number 4, but after this 1 comes the number 3. So it's a non-repeating decimal. Let's try another one, the square root of 3. And you see here non-repeating decimal because after the 0 comes a 5, after the next 0 comes an 8. So it's a non-repeating decimal. Let's try the next one, square root of 5. Here we have another one. After the 6 comes a 0, after the 6 comes a 7, after the 7 comes a 9, and after another 7 comes a 7. So non-repeating decimal, there's no pattern to it. Those are called irrational numbers. So that's the first thing I want to know. I want you to know that we have rational and irrational numbers. So surds are irrational, right? So surds are irrational numbers. And for surds and manipulating surds, we need to know our square numbers. 1 squared, 1, 2 squared, 4, 3 squared, 9, and so on. So most of you will know them up to 100. Some of you will know up to 112 squared. It's also handy to know 13 squared, 14 squared, and 15 squared, and also 16 squared, which I think is 256. After that, I can't remember. But we're going to be simplifying surds. And to simplifying surds, you're really on a hunting mission to expose those square numbers and convert them into the roots of square numbers to real numbers. Okay, so we're going to have a look at some surds, and this is what the exercises are on. This is what I would have taught when we were back in, if we were back in school. So we're going to start off with the square root of 50, and we're going to convert the square root of 50 into a surd. So we need to hunt out any square numbers. Well, will 4 fit into 50? So we're looking at 4 and probably 20, 25. 4 won't go into 50 evenly, but we know that 50 can be expressed as 25 times 2. So we could split this up into the square root of 25 times the square root of 2. And the square root of 25 is 5 times the square root of 2. So we convert 50 into 5 root 2. Okay, I need a bit of feedback at this stage. So I'm going to ask you in the comments section down here if you understand that. Just put yes or no in the comments section. Hold on, I'll move this across so I can see. Okay, so I've got quite a few yeses. And I want to know if anyone doesn't understand so that I can help you. I'll just get my screens adjusted a bit so I can see those comments at the same time. Cool. So most of you saying you understand that. So let's do a few more examples. And as we do a few more, whoops, we've already started. Right, so do a few more examples. Square root of 48. We want to make that surd form. So I think, well, 4 fits in nicely into that. So I can go 4 times 12. I can see that 4 fits nicely into that. So I can go 4 times 4 times 3. So 12 is 4 times 3. Or in other words, 16, which would perhaps should have been my first guess. 16 times 3 is 48. So I didn't really need to do these first two here, but that could have been a way that you got there. I could have just said root 48 is 16, root of 16 times 3. So we take the square root of 16, which is 4 times the square root of 3, and 48 equals 4 root 3. So that's putting a number into surd form. Yep, Wesley got it earlier than me. Sorry, I wasn't looking, Wesley. So we've got that idea. Then what about when we combine it then? I'm going to assume that you are understanding really well. What about if we combine it with this? Say we had 25 c to the power of 8, d to the power of 16. 25, 5 times 5 is 25. And the square root means we halve these powers, c to the power of 4, d to the power of 8. So remember that the square root of x equals x to the half. So we're halving the powers, but we're not halving the numbers. Numbers and powers behave differently. Okay, let's try something like the square root of 108 a cubed bc4. Square root of 108 a cubed bc4 equals. Right, so what are we going to do? That's 100, by the way. Let's make this a little bit clearer. Right, so what goes into 108? We know that 12 times 9 is 108. 4 times 3 times 3 times 3. Okay, so we've got 9 times 4 is 36. So I could write this as 36 times 3 is 108. I could write this as a squared times a is a cubed. And we've got b there, and I could write c squared times c squared. So what I'm going to do is I'm going to show you where my roots are. That there is 6, square root of that. That there is a when I square root that. And that there is c, and so is that c. So c squared. So when I convert this into an ordinary number, taking out the, into surd form, I have 6 as my whole number. I have a squared. The square root of a squared is a. I have the square root of c to the power of 4, which is c squared. And the rest stay under surd form, 3ab. Right, have I gone too fast? Yes, if I've gone too fast. No, if it's okay. Please type it in there. Yes or no, whether I've gone too fast. 1, 2, 3, 4, 5. 5 of you have said no. 6, no. 7, no. You know, you people are making me feel good, except one student last week told me, oh, they just put no, even though they didn't understand it, but they didn't want to feel different. So if you're not understanding, you can go back and you can review this video again and get some extra help. Okay, let's try something like this then. So I'm moving along reasonably fast, so I hope I'm not losing you. Please tell me when you start getting lost, because then I'll slow down. I said I'm going to finish within 9 or 10 minutes, so you won't have to wait much longer. X squared minus 6x plus 9. Can we simplify that? Well, we can factorize. You need to be good at factorizing also. So this is a quadratic and 2 pairs of brackets. So the x squared is xx. The last number is positive. The middle term is 2 of those. And the factors of 9 that add to 6 are 3 and 3. So that's like saying the square root of x minus 3 squared. And the square and the square root cancel out. So the answer is x minus 3. Okay, so that should be good. Now, what about if we have to simplify? Sometimes we're asked to simplify surd terms. And this one here looks tricky. It's 2 root 5. By the way, I'm copying these out of a textbook. I'm not making them up in my head. 3 over root 125. Okay. What would be my first thing to do? I would look for a square number in this part. Is there any square number in that part? And I think it would be 25 times 5, I think it is. Check it on your calculator. So we go 2 root 5 over 3 root 5 times 25. Now, when I take the 25 out, that becomes 15. 2 over 3 times 5, which is 15 root 5. Whoops, the root 5 still stays at the top. And now I can cancel out that root 5 with that root 5, and I get my answer as 2/15. So something like that looks quite complicated as a surd, we can simplify down to 2/15. Type in a tick if you understand, a yes if you understand that, please. I want to know, am I getting through? Yes if you understand. Cool, one person. But I'm also getting an idea when you type in there of who's in class, because I'll be taking the role. I've got most of you down. I see Jazraj is here. Just let me know if any of these people are here, please. Type in if you're here. Sean, Donyon, Dashil, Kiani, Stephen, Isabel, Bilal, Hadi. Those are the Famara and Fatima. Those are the ones that are. Oh, Fatima's here. Good, I see you there. Any of those here? Stephen's here. Good. And Isabel's here. Good. And Famara's here. Good. And I think I've got everyone else. Cool. Okay. We're going to one more type, and then I'm going to finish, and we'll see how we get on. So what if we were to do and simplify, say, the square root of 56 minus the square root of 14? You asked to simplify that. Remember, we're on a mission hunt to search out the square numbers. So are there any square numbers in here? 14. Oh, 7 times 2. Can't see that. 3 times 7. Right. I can see this. I can see 2 root 14 over root 14. Good. So we've got that 56 is the square root of 4 times, 8. No, yeah, 4 times 14. Here's 56 minus root 14. And so that is going to equal square root of 4 is 2. 2 root 14 minus root 14. Okay, and what does that equal? This is 1 root 14, and that's 2 root 14, which is actually just the square root of 14. Remember that 2x minus x equals x, because we've got 2x minus 1x equals 1x. So here we've got 2 roots 14 minus 1 lot of root 14 is 1 lot of root 14. So we've got the square root of 14. Can we simplify square root of 14 down any further? I can't see any square numbers in there, so I'm going to leave it like that and presume that I've simplified that surd as far as possible. Okay, let's go over what I need you to do. I need you to go to Google Classrooms and then click onto HN, where you will find under, whoops, I've got the wrong class here. Let's go to Calculus. Calculus, we are doing, whoops. Calculus, we're doing complex numbers. And you've got videos there on complex numbers. You've got train-sum activities to do for Surds 1, Surds 2, and I will be putting extra things down here for you to do. Okay, so it'll be under the HN. Now, you can work independently. I am going to be available for you if you would like to continue to stay online and ask for help. Bilal, you've got here. Good. So you can stay online and get help if you like. Otherwise, you're to work and keep your work going. And I will see you again if you choose to log off. Do your work, and I will see you again at 8:50 tomorrow morning. And enjoy your lockdown. But if you have questions or you want explanation, please stay behind if you want to go over the conic section and need a bit of help, stay on. Otherwise, just say goodbye and have a good rest of the lockdown. I mean, have a good rest of the day. Yeah. Thank you, Leon. One not going to be possible to be shared on Google Classroom. I will try, but I've had problems doing it, Celine. So I'll see if I can get it to you. Thank you, Stephen, Julius. Thank you, Ruby. Bye. Thank you, Tian. Yep. Thank you, VJ, Colin. Bye. Thank you, Esther, Fatima, Mara. Thank you. Kyle. Yep. Oh, thanks, Wesley. Boss. Good. Thank you. Yeah, Abhishek. Cheers. Yep. Jezraj. Bye. Salon. Celine. Bye. Thank you. Bilal. Bye. And Dash. Oh, Dash is here. Good. Dash.
Hey, Mr. Hamilton. Sorry I woke up late. Just wondering what you went over this lesson.
So who we got here? Well, Bilal, do you have some questions you want to ask me?
Yeah, Mr. Hamilton. Sorry for coming in late. Just wondering what you went over this lesson.
Bilal?
Yep. Is my mic working?
Bilal, if you are trying to talk to me, I can't hear you. Oh, your microphone isn't working. Can you type any message in? Okay, Bilal, I'm going to put this lesson up on Google Classroom shortly so that when you go into, go to Google Classroom, sorry, let's go here. No, I need to present to you. Wait a minute, I'll present to you my screen and I'll show you exactly where you need to go, right? So that you need to know what to do. So I'm going to share my entire screen. So hopefully you can see my screen now. So what you do is you go to Google Classroom and you go to the Google accounts and you go to CAL3 and we're going to do complex numbers. When you go to complex numbers, you've got these activities here. And at the bottom here, I'm going to upload the video for this lesson. And when you get this video for this lesson, you'll find it here and you can find out what we did. All good? And I'm going to stop recording. Cool. Thank you.